Astronomers estimate that the universe could contain up to 1 septillion stars. Our Milky Way alone contains more than 100 billion, including our Sun. Stars are giant balls of hot gas, mostly hydrogen, with some helium and small amounts of other elements. Do you know how it really forms? Stars form in large clouds of gas and dust called molecular clouds, which range from 1,000 to 10 million times the mass of the Sun and can span as much as hundreds of light years. Molecular clouds are cold, which causes gas to clump, creating high-density pockets. Some of these clumps can collide with each other and collect more matter, strengthening their gravitational force as their mass grows. Eventually, gravity causes some of these clumps to collapse. When this happens, friction causes the material to heat up, which eventually leads to the development of a protostar. Ever wonder how stars like our Sun are born and shine for billions of years? It all begins in a stellar nursery, a cloud of gas and dust. Over hundreds of thousands of years, the clump gains mass, starts to spin, and heats up. When the clump's core heats up to millions of degrees, that's when nuclear fusion kicks in. This process occurs when two hydrogen atoms merge to form one helium nucleus. Fusion releases energy that heats the star, creating pressure that pushes against the force of its gravity. A star is born. These stars range in size from 1/10 to 200 times the Sun's mass and live for millions to billions of years. And here's the crazy part. About 90% of the universe's stellar population are main sequence stars. Our Sun is 4.6 billion years old, and it still has about 5 billion years left before it swells into a red giant. Want to see a main sequence star tonight? Just look up at Sirius, the brightest star in the sky, or Alpha Centauri, our closest stellar neighbor. Ever wonder what happens when a star like our Sun dies? When a main sequence star, less than 8 times the Sun's mass, runs out of hydrogen in its core, it starts to collapse. Do you know why? Because the energy from fusion is the only force pushing outward, balancing gravity. Without fusion, gravity takes over and the core starts collapsing. But as the core squeezes, temperature and pressure soar. Helium starts fusing into carbon, releasing energy too. This triggers hydrogen fusion in a shell around the core. The energy from the shell pushes the star's outer layers outward. The star swells into a red giant, which would appear more orange than red. Eventually, the red giant becomes unstable. It pulsates, expands, and ejects parts of its atmosphere. In the end, all of its outer layers blow away, creating an expanding cloud of dust and gas, which forms a beautiful planetary nebula. And our Sun, it will become a red giant in about 5 billion years. From a glowing giant to a sparkling nebula, this is the life and death of a star. Ever wonder what happens when a red giant reaches the end of its life? When a red giant sheds its atmosphere, only the hot core remains. Scientists call this kind of stellar remnant a white dwarf. It's about the size of Earth, but hundreds of thousands of times more massive. Just 1 teaspoon of its material would weigh more than a pickup truck. A white dwarf doesn't make new heat. Instead, it slowly cools for billions of years. Sometimes, scientists even find them surrounded by dusty disks of material, debris, and even planets, leftovers from their red giant past. And one day, about 10 billion years from now, our Sun will become a white dwarf too. There's a type of star that should exist, but doesn't. Astronomers call it a black dwarf. Black dwarfs are the final stage of dead stars. They form when a glowing white dwarf slowly loses its heat until it fades into darkness. White dwarfs are typically about the size of Earth, but hundreds of thousands of times more massive. Just a teaspoon of their matter would weigh as much as a truck. But here's the twist. The universe isn't old enough for a single black dwarf to exist yet. Cooling takes trillions of years, far longer than the universe's current age of 13.8 billion years. Someday, trillions of years from now, our cosmos could be filled with these cold, dark stars' corpses, a universe without light.